Hello, in this video we're going to take a look at a couple of different Japanese switch types and how they can be fixed. Very often these switches on these old 1960s Japanese guitars, they go bad, they start to lose connection, and you have to inevitably at some time or another take these out of the guitar and apart and fix them. In today's video we're going to take a look at two different types of these switches that are the most common, and the ways to get them apart, to clean them properly, and also to fix them. If that's something that tickles your fancy, stick around and we'll take a look at that now. Okay, the first switch type we're going to look at is the one that was in the guitar that we just looked at. Here is that very guitar out on the bench open. Here are the bottoms of the switches. We can see that we have a cap to ground on each one of these, and that's on the solo switch. And we'll just run through some photos here. There's the swimming pool route for that guitar. And strangely enough, that had a number in there. I don't know if that's some kind of serial number or body number for the factory. There's also a number stamp here, number 3. Pretty interesting. These guitars, these Kawais from the mid-60s, are really nice guitars. This is actually a solid, I think this is a single solid piece of mahogany is what the body of this is made from. So very good quality. Not what you typically think of sometimes when you think of Japanese guitars, perhaps, but this is a really nice guitar. Here are the underside of the switches. We can see them a little more closely. Let's zoom in a bit here. Again, we have our caps. This is the solo switch here, and then we have two on-off switches for each of these pickups. In pairs. Here's a close-up. Says something on them. It's like S-E-L-I-O. I'm not sure what that is. There's another stamp over here. At any rate, this whole thing is pretty much riveted together, and we'll look at how to. You can see this the end of the shaft that holds the whole thing. That holds the switches on, that they kind of rock back and forth on, and this is going to have to come out in order for us to repair the switch. There's another shot of them. We'll probably go through several different shots. I'm kind of a wild and crazy photographer sometimes. Here is the switch out of the guitar on the top. You can see this little piece right here. We will look at where those go in just a little bit. They actually go underneath here. They slide in, and you have to get those out. See, there's a little hole you'll notice. Let's back up actually, and you can see the hole. That little hole right there, there's a nub on the bottom of each one of these switches that is supposed to sit in that nub, and as you rock this switch back and forth, that little nub pushes this whole piece forward and backwards along the bottom of the switch. When that nub wears away, because it's plastic, it's actually molded in with the original switch, and inevitably it is going to wear away. The more you switch this thing, the more tiny pieces chip off. Eventually it's going to break, and you'll be left with a switch that doesn't work. And that's almost a guarantee with these. And we will get to that in just a bit. Here's the little piece installed in there, and here's a better look at the end of the shaft we will have to remove. This is from another angle. Pardon me, some of these are kind of hard to see, but you can also see how dirty these get. I mean, there's just dirt galore down in here. And you know, this gives you an good opportunity to spray all this out and clean it with a brush, and get everything nice and clean too while you're at it. But really, it needs to be done on these old Japanese guitars. This one was exceptionally clean too. You wouldn't know it by looking at the switches, but this guitar looked like it hadn't been hardly played. Okay, here I am. What I've done here is taken a pair of pliers and actually smashed the ends of this thing to the point where it's no longer like a rivet on the end. I'm actually straightening it out so that I can get it back through this hole. And we'll see here. There we go. It's actually, now it's going down into the hole. So you have to actually reshape the end with some pliers. So that involves some squeezing. One way, then you have to turn it and squeeze again, and then you create a a square on the end. You have to keep going until you get more or less a circle, and then you can start to pull the shaft out, and this whole thing will come apart. There we go. They're starting to come apart. These will come off, and you just want to take note of where everything goes and how it's all together. We'll see a bit of a closer look here at where the nubs were supposed to be. You can see like just a little circle there, and there's a little remnant of a circle there. None of these had any nubs left at all. There was no switching going on whatsoever with any of these. There's a better look at the little circle that the nub is supposed to set in. Yeah, there I'm pointing out where the nub is supposed to be. But look how grimy this is. This is what's supposed to make and break your connection. Whenever this slider slides across this connection, it actually sends the signal for that particular pickup to ground. So it grounds out the pickup essentially. So when you disengage the switch, that's when you're turning the pickup on. All the pickups are on naturally, but when you switch, you're actually grounding them. But look how nasty those are. I mean, that's what I basically did was I just sprayed the heck out of it with some contact cleaner and brushed them with a brush. Now here what I'm doing, and you have to kind of get creative with replacing these nubs. And what I decided to do was drill holes where the nubs were supposed to be. Now I'll figure this out later and we'll go into it a little further. Don't drill down too far because you don't want to go all the way through into the shaft. If you do, it's not the end of the world. You can fix that, but it just requires an additional step that you don't have to take if you don't go all the way through the plastic. So I'm going to drill a little hole where each one of these nubs should go. And here we go. There's a better look at it. And you just want to drill a hole straight in, and again, don't go so far that you end up poking through into the shaft area inside. It's not the end of the world if it happens, but it just requires another step to make it right. Here we go. There's our hole, and I accidentally did go too far with a couple of them, and we'll show the fix for that as well. What this is some copper wire that I've stripped of its insulation. And we're just going to use little strands of this copper wire down in this hole. So first thing we have to do is cut a few lengths of the wire and put them down in there. In this case I used 4, and that filled up the hole nicely for the size of bit I was using. Then you want to get some Gorilla Glue and just dab a little on the area, and this will have to dry for a long time, so you'll want to leave this pretty much overnight and let it set and let it cure really well. But you want to put some glue, just basically coat it in glue. You can see what I've done here. Just coated each one of these in generous amounts of glue. You're going to come back in here anyway and file these down into shape so that they'll fit the holes anyway. So if you put too much glue, it's not a big deal. You're going to be filing some of that glue out too. But here we are testing it. So I'll put the shaft back on to test and see how far it's going down, and I realized I needed to file a little bit more. So here we are filing. And for this I'm actually using, I think this is one of my wife's old nail files or something. It's like a Revlon nail file. But you can use other files too. I just happened to have that one close by and it was doing a good job. But you can see the difference here. This one's I've started to file on, and this one's still rough. Here we are with a completely filed one, and you can see how round it is in there. And that's what it should basically look like when you're done. And that sits right in the little hole, and that's what pushes this back and forth. When you rock the switch, it pushes that whole thing back and forth like it's supposed to. And since that's, you know, super glued in, and it's copper, that's not going to wear out anything like a piece of plastic is going to wear out. So these probably should be good pretty much forever, I guess, until somebody opens them up and screws with them, I guess. But here are the three, and again, I think I had to take this back. I'm just testing it at this point to see if they're going to work. Here they are back together, and you can see the little sliders there. Okay, this might be a little bit difficult to film, but I'm going to show. This is the these are the three switches that I've done so far. I don't know if you can see it or not, but down inside there are the little copper nubs down here, which I've installed to make these work again. The original plastic nub, which was molded in with this piece, was long gone. Those get chewed off. This one here still has two of the plastic nubs. You can see one peeking through right down there, and the other one you can see here. You see the difference here in the middle. You don't see that little plastic nub down in there, and that's what makes this little slider here work, and it bridges this connection to ground. So whenever this is pushed on, it actually disconnects. So you'll see this little, you'll see the little slider when I move this thing. See that slider down there moving as well. This one over here actually works too, and you can see the slider moving as I press down. But this middle one, you notice when I push the button, the slider doesn't move. The button moves, but the slider does not. That's because that nub is not there, and that's why the switch doesn't work. So that's why we have to take these apart. Now these screws, well, I say screw, but this this riveted shaft that's running through here, this little axle shaft that holds everything together, this has been just smushed off at the end, just bent, probably by machine, so that it doesn't pull back through. What you have to do is get in here with a tool and just squeeze on one side, squeeze on the other side, and then just basically you have to shape it with a pair of pliers until you can get it straight, and then smoothly just pull it all the way out. And then whenever you're reinstalling it, like I said, this one's completely done and back together. Whenever you're reinstalling it, you can just smush it with your pliers one way, and you can see there how that's been. There we go. Now we're focused. You can see how that. I just took some pliers and crimped that off so it can't pull back through. And that's it. That's how you get one of those apart, and that's how you fix this style of switch. Now there's another style of switch we're going to take a look at in photos as well, which requires a completely different method for fixing it, and we'll take a look at those as well. Well, I actually had this thing all back together, and everything appeared to be working for the most part, except I was having some problems with the switches still, and went round and round and round with this, and eventually realized that as I was drilling the holes for these little nubs, on a couple of these I actually messed up and went all the way through the plastic to the inside. I don't know if we're going to be able to see inside this hole or not, but inside that hole, actually, I went all the way through. So the problem is, because I went all the way through, crap, I can't get a good focus on anything. I think this is probably the last iPhone I ever buy. Everybody's like, oh, it's such a great design, but it's actually a piece of shit design. Don't ever buy an iPhone. The reason it's a piece of shit design, the iPhone, is because, first of all, the son of a bitch is square. You can't hold it. There's no ergonomics to it whatsoever. Oh, but it's so beautiful. It's Steve Jobs is so freaking beautiful. But you know, I could probably rant about this all freaking day. The number of times I've dropped my iPhone because I couldn't hold on to this stupid thing, and plus it just doesn't want to focus. Anyway, this is probably the last. There we go. You can see inside. I went all the way through. So when I put the little copper pieces in, the little pieces of wire, they are actually, unfortunately, making contact with not only the piece of brass, that piece. So they're not only making contact with that, but they're also making contact with the shaft that holds them in place. This piece. So if they're making contact with that, they're making contact with the bracket, and since this is screwed onto this, it's making contact with common ground throughout the circuit. So stupid me. I mean, best laid plans of mice and men Afghan Glay. Apparently, I forgot that little axiom and have screwed myself there. So what I've got to do is come up with a creative solution. I could either pull this out and start over, halfway fill the hole and then re-drill it, but not go all the way through. So that's one approach. Or I could do what I think I'm going to do, which is mark the point on the shaft that lies exactly in the middle, over the part that I do not want to contact, which is, you know, right there, right in there somewhere, and kind of mark it off, and then find every single one of these that I accidentally went through on, and mark it off, and then come in here and actually file this shaft just in the center, and just enough all the way around so that no matter which way it ends up turning, that it can never make contact with that little center dimple of copper. So, yeah, stupid me, too smart for my own good. Now I've got to fix things. But yeah, that's just kind of a good lesson. If you do one of these like this, just make sure you don't go all the way through the plastic. And if you do go all the way through the plastic, just realize that whenever you put your copper in or whatever you use, it probably would be best to find little pieces of something non-conductive. But if you do use copper like I did, something that's metal is going to last a long time. So that's one good reason to use something metal, and plus you can file it into shape. But you just got to be careful that you don't end up with that same problem I just ended up with. Okay, all three of the switches on this particular switch had I had gone all the way through on all three of these. So you'll see here what I've done is I've actually dimpled this shaft in all three places, right above where the copper will poke through on the inside. So no matter which way this spins now, that little bit of copper should not ground out against this shaft. Another good thing that this might have a consequence of is this should kind of reduce friction as well, because each one of these little switches, they'll have less contact point, and this whole area won't be contacted on the inside of the switch. So I guess in one way it should make the switches work a little smoother, but we'll see how it works out. It might actually make them work too smooth, because you don't really want them to be able to flip back and forth real easily, but we'll see how it goes. I think this is going to do the trick, but fingers crossed. I might have to go to a different shaft, maybe something, or coat this shaft in something. I don't know. I might even have to just go back and take those nubs out and do something different. But I think this might take care of it, but we'll see. Alright, here's kind of the fiddly bit, getting all this back together. Before I smash this little shaft back on here, because I've already had to smash it in twice now to remove it twice. So any more than that, I think I'm not going to have very much metal left on this end. So I'm going to get these back together and then test it and make sure that it's okay before I smash that end. But these little bits right here, what you have to do is you have to kind of squeeze these together, and then it's going to be real hard for you to see, I know, but you have to kind of stick them in like this at first, and then get like a little implement, a screwdriver in this case is what I'm using, and you can get it right on the little hole and push the little hole down in there, and then it should snap right into place right there. Yep, snaps right into place on our little dimple that we created. And that's working smooth. This one's already on and it's working smooth as it should. I'll tell you what, the dimples that I created actually are working perfectly. So that's a good thing. And here's the last one. Let's go ahead and put this one on. Yeah, what kind of tipped me off to the fact that these weren't working right was, you know, the switches were a little bit intermittent, and they shouldn't have been. Like I said, everything was working beautifully, and they just were working really intermittently and doing some funky stuff. One minute they would work, and then they wouldn't. And then this, the cap that gets engaged when you engage the solo rhythm switch, it wasn't working at all. Only in certain points could I press down on the switch kind of hard enough to make it come on instantaneously and then go right back off. And that kind of tipped me off. It's, well, something's not right. And I went through here, flowed solder, and did all that crap, and then it turns out to be something stupid I did, of course. Still kind of kicking myself over that because I really didn't want to take them back apart again. It's never something that you want to have to do multiple times, but oh well. Okay, let's flip this on, and then we can test these. I should be able to get this done like this. I'm just going to plug it into the amp. Little test amp here. Alright, let's turn it on. Now then, I'm going to turn everything off over here. Let's turn all these off too. Actually, we'll leave this one on, so let's check that one. Okay, that's working as it should. Let's check it with the rhythm or the solo engaged. It's really hard to tell when that solo is engaged. Let's try this. Let's bring my switches out to the back. There we go, like that. Now we can tap to our heart's content. Alright, let's do that. Okay. The switch is working perfectly. It's acting like it wants to work. There it goes. Yeah. Oh, shoot. Yep, it's going wobble 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 wobble. Perfect. So I'm happy with that one. Let's get that smashed back on there so it doesn't come apart, and then let's open that one up and see how many of those I screwed up. Oh yeah, I guess I should demonstrate what I'm doing there. All I'm doing is taking a pair of pliers, and then this end of the shaft that pokes out on one side, I'm just grabbing it with the pliers and just squeezing real hard to bend this into place. Let's give it a good squeeze. I'm going to push in first. Make sure we get it in a good spot. Basically all we're doing is we're misshaping the end of that so it can't possibly pull back through. And that's good to go. Now on this one that we need to take back apart, we're going to do the exact opposite of what we just did. So what we have to do is come in here And again, this one's already been smashed twice, so I just have to be real careful about not kind of breaking off any metal, because that's going to render the shaft useless, and I don't want to go trying to find a substitute shaft for this thing. So what I'm going to do is just gently kind of squeeze with my little pliers here until it gets to the point where it'll slide back through. And I don't think I didn't even have to do very much to that. That was barely hanging on anyway. It was on, but it was barely on. Alright, now our shaft, you see there, slides right out, and this whole thing comes apart. You can see there where I've smashed it a couple times now, and that end is not looking very pretty. So I'm going to make sure that next time I do it, that it's the last time. So what I want to do now is take these pieces apart and make sure I don't lose anything. Obviously, let's turn the amp off. We don't need that on. Okay, so here's all of this. Here's our contacts. What I want to do is just kind of mark my shaft. Actually, I can actually see the markings on the shaft. But what I want to do first really is see how many of these I have to actually do, because I don't want to overdo it. So yeah, I'm just going to do the one. And here's what I'm doing. I'm just using my Dremel. First I need to mark it. And it's one of my on-off switches, so I'm going to make sure I put it in the second position. Let's put it in this position. First I'll mark it. No, actually I'll put it on the end position because it's already scratched anyway in that area. So let's make it the first position, and we will get it right there. So what I'm going to do is let's get my Dremel. There we go. I don't want to go too far this way or that way because I want the switch not to move on the shaft laterally. I want it to only be able to turn this way. So yeah, I think that is going to take care of that. So I'm going to put this in the first position. Alright, and we'll make sure we get this the right direction also, because that'd be really stupid too to put them on the wrong direction. And they all the off positions and and everything face the same way, so I want to make sure that's right for sure, because I really don't want to take this shaft off another time. Hopefully this will be the last time it ever has to come off. I think with these metal nubs, that this very well could be the last time this ever has to come apart. If this had been done from the factory, with a bit of metal in there instead of that plastic, first of all, I'm not sure how they would have manufactured that, but it definitely wouldn't have broken. Alright, again we're going to squeeze these little guys just to test them first. There's one in. Let's get my little screwdriver, there we go. And again, I'm just getting my little implement down right there in the hole of the contact. I'm going to push it into position. There we go. You can hear it snap into position, and that's working as it should. Let's go ahead and just put them all three back together, and we'll test the whole switch. We might as well. That second nub right there is rubbing. That sucker's actually rubbing. Huh. Oh, I can see why. I can see why it's rubbing, because the bracket's actually somewhat bent. Probably when I was screwing with it earlier, I kind of bent this bracket, so actually, let me get this back apart. Let's pull this back out. And these can fling on you. You gotta be real careful about these because they're like springs and they'll fly. Now watch it fly. As soon as I say it. That's the kind of shit that happens to me. Especially anybody that's watched a few of my videos, you kind of realize that, oh yeah, he's kind of a dumbass in some ways, isn't he? So here we go. Let's see. Let's actually just very lightly, because this thing is all on a bracket. I don't want to break it, but I do have to bend it. So let's just bend it a little bit, ever so slightly. I don't want to break the wafer. That's what I don't want to do. But there we go. I think that is pretty straight now. I think that's better. I don't think it'll rub now. Okay, one last contact to put in here. Let's see if I can do this in a way where you can actually see. There we go. Just pushing it underneath, and it kind of snaps into place for you right on the nub. Alright, now this is all back together, and then let's check these two pickups and see how they're working. Okay. Let's see, first of all, let's turn those are off. Let's turn this one on. Perfect. Oops. Oh yeah, listen to that difference. Huh. Well, that kind of makes me wonder about these then, because that's a lot bigger of a difference in tone than this one was generating. Yeah, it's almost like this one isn't engaging right. Maybe it's still screwed up in some way. No, okay, I know what it is. Actually, with these are actually all in series, so both of these switches work on all of the pickups, so we're okay. Okay, one last contact to put in here. Let's see if I can do this in a way where you can actually see. There we go, just pushing it underneath. And it kind of snaps into place for you right on the nub. Alright, now this is all back together, and then let's check these two pickups and see how they're working. Okay. Let's see, first of all, let's turn those are off. Let's turn this one on. Perfect. Oops. Yeah, listen to that difference. Huh. Well, that kind of makes me wonder about these then, because that's a lot bigger of a difference in tone than this one was generating. Yeah, it's almost like this one isn't engaging right. Like maybe it's still screwed up in some way. No, okay, I know what it is. Actually, with these are actually all in series, so both of these switches work on all of the pickups. So we're okay. Actually, and I had drawn this out as well, desperate for some solution. I didn't draw the whole thing, but I'd started drawing this out. I'll probably take a picture of this, and when I'll finish this up, drawing this out, and I'll take a picture of it. So if anybody has one of these and they want to try to troubleshoot it, or if they, I don't know, if you want to try to wire up your own, actually, get you 4 single coil pickups, and you can do it exactly like this. But I will post probably a link to that in the description. So yeah, I think we're ready to smash this end, because that's working perfectly. So let's go ahead and turn this off and smash that end and get this guitar finally back together. Let's see, okay. Now again, this is the last time I want to have to do this. And I definitely want to get it right. So let's make sure we do it right. Get it over here. Get a good grip on it, and just basically you want to smash it so that it can't go back through. Yeah, it's going right back through. Damn it. Let's see. Well, what to do in that case? Maybe I can bend it over. I've got to be very careful though that I don't, if I'm going to bend it rather than smash it, I have to be very careful. I'm going to stick with the smashing idea. If I try to bend it, I'm afraid I'm going to break it. It's going right back through. So let's go ahead and bend it over slightly. I might get a different tool though. Let's see. Grab it with this, see if we can bend it with this. We just want to bend it to the point where it's not going to come back through on us. We definitely don't want that. Well, that was odd. The last portion of my video got interrupted by a call from a guy running for Attorney General in Indiana. So I had to break the news to him that I no longer live in the state of Indiana. So really couldn't help him much. But yeah, these are all back together, working smoothly. Let's go ahead and check them one more time just to be on the safe side. I'm thinking nothing would have changed, but let's see. Here's number 1. We're good. Number 2. Yep. There's our solo. It's clearly working. So yep, that's definitely changing. Here's this neck. Yep. Here's this one. And that's for sure. I mean, that's working like the dickens. See, this one will also go that high if you have both of these in parallel. See, these are actually paralleled to ground. This one's just in a different position in the circuit than this one. But when you have multiple caps going, seems to really brighten things up. This thing is going to sound killer, I can already tell. But these are working absolutely perfectly. They're perfectly smooth. They stay in position. You don't have to press them down. There's not even a hint of any problem with any of these. They're completely noiseless. You can see there, the only noise is the physical switch itself. Which, I mean, hell of a Stratocaster switch makes more noise than that. So that's as far as I'm concerned, this is a win. Those are perfect, completely refurbished, ready to go. They're actually better than stock. If you want to do this on one of yours, that's the way to do it. You can learn from my mistake. So. Well, I figure before we move any further, I'll go ahead and publish this schematic here in case anyone wants it. I'll also put a link eventually in the description to a cleaned up version of this if you want like a PDF or a JPEG or something. But if you want to pause the video, here's the schematic for the thing here. Okay, now we're going to take a look at a second type of switch. Here we see a 2-button switch, and this is done in a completely different way underneath. This is probably the more common of the two. You'll come across these quite a lot, and here's the way that they work. Inside, underneath the switch, what you have is two strips of metal that come up that are bent. Actually, they're one piece in with these as well. That's all one piece if you take it apart and look underneath. But you have these pieces sticking up, and then you under the plastic. Inside there you have a piece of metal as well that bridges the connection, and we will take this whole thing apart here and look at it too. Here's the underside of it after it's back together. Actually, these start out with rivets and you have to drill them out. So it takes some creative solutions to get these apart. Let's go the other direction. This is actually after the fact. I didn't think to start even taking pictures of this process until I was already done, so that's why we're looking at a completed photograph. But let's go back to the beginning of this photo set. Here we go. Okay, here's everything apart, and you have to do the same thing with the shaft that you did on the other one. You have to bend the end of it and slide it back through. Here we see the wafer comes apart. Here are all the little pieces, and this gives you again an opportunity to clean all this stuff thoroughly, which is a good thing. Again, this piece was held on with rivets. So you had to drill those out and then use a screw to put it back together. Just a better look of the pieces. This piece right here is a piece of wafer board that I had to cut in order to make this one work. And that's what you want to do. You want to find something that's non-conductive, and you'll have to cut another piece to put on the bottom of this to hold everything together, because what happens is these pieces, these contacts right here, they bend and they try to fall apart, and they won't make good contact because the wafer board wears out over time or cracks even, and it won't hold these in place where they can get a good connection. So usually the source of the problem on these is this wafer board, and you have to make a piece to get this back in working condition. So get your saws out and cut a little square the same size as this and drill your holes. And you can see here better what I mean by these not staying in, because when you switch the switch, it actually pushes downward on these little pieces. And if the wafer board underneath isn't strong enough to hold them in place, then they'll just push straight down and crack the little wafer. Here's everything back together. Here are the screws I installed. The new wafer board is underneath this board, so they're packed together. And then you have these contacts in between the two pieces. So when the switch comes down and it pushes down into here, these two pieces will spread apart and they won't push downward and and break this wafer board. And actually, I got one that was stronger as well than the original. Here's the bottom. But yeah, this is going to be good for a long time too. This is actually better than factory. In both of these cases, the outcome is better than the factory switches. So you shouldn't have any more problems with this switch, hopefully ever again. But if you do, it's just probably going to be a matter of cleaning the contacts. But yeah, there is the second type of switch. Hope you've enjoyed this video. Please subscribe for more videos like this, and hope to see you again in the future.